When working in PowerShell, quite often we will use variables to hold data that we have created temporarily until we can use it. In PowerShell, you're going to find very quickly that you generate lots of data related to other data you're using, as opposed to Bash, where each item tends to be fairly separate. When we need to put multiple items together, Bash gave us the array mechanism to create lists of data that we could then use. But each data item was still a simple data item. In PowerShell, we've already learned that objects have a great deal to them. They are built from members. They can have methods, they can have properties, they can have different kinds of properties. Those properties themselves contain objects which have types. They can contain more things. It's much more sophisticated. Not too long after starting to use PowerShell, you will discover that it's to your advantage to create your own objects to store things. The simplest use of this is to treat them like variables, to create an object as if it were a variable, the difference being that it's more sophisticated. The object that you've created to store things in can hold multiple items, each with their own name, each holding their own data. And those objects that they hold can themselves be objects of your own creation or of standard system types, each containing their own data and their own list of things. Creating objects in PowerShell is very, very simple. We've been doing it on the command line. If we were to type in a number, we would create a number object. If we type in text surrounded by quotes, we're creating a string object. If we put in a number with a decimal somewhere in it, we're creating a floating point object. If we run a commandlet, we can use it to create one or more objects, all different sorts, different kinds. We've been doing this all along. One of the things that all of these objects have in common is they are predefined object types. Predefined as to what can be in them, their structure, their properties, the names of the properties, and what kinds of things they can contain. To create your own objects, one of the commands that you can use, a nice simple one, is new-object. If you run new-object, you're going to need to tell it a little bit about the object you want to create. You're going to need a type name to start from. So when creating an object, we have to begin with some kind of existing object that we can either add some things to or take some things away from or modify in some way. If you're creating generic little objects to use for storing data of your own creation so that you can have your own list of names and properties, the simplest one to start with is usually called ps_object. It's a fairly empty object. It just has a few little methods in it, like equals and get type, and doesn't have any existing properties. So you can create your own, and you know that the objects you're creating will be compact, they won't use a lot of memory, and they'll contain exactly what you want and only what you want. To put properties in the object, there are a number of different things we can do. We can use add property methods and things like that. Or we can specify a list of them when creating the object with the -property parameter. If we specify them with the -property parameter, the way you list your new properties is you use @curly brace to open the list of properties. You then specify each property as having a name and some starting content, something to put in it, an object or a collection of objects. So you might create one that has a property that has the name. To assign a value, we put the equal sign and we put something that creates an object. If I put in a string, I'm going to want quotes on it. If I want to create more than one property, I can. If I only want one, I'll just close my curly brace. This would make me an object The object is fairly empty. It has one property in it, and that property contains a string, currently with the value in it, my name. If I wanted to add more properties to this when I'm creating it, to have more, I use a semicolon after the first property specification, and now make another property the same way. Some property name, then the equal sign, and then what do I want to put in it? And I can make as many properties as I like. It will make me a new object. Since I didn't tell it what to do with the object, it fell off the end of the command line. PowerShell catches those and displays them. The default display for my object, since my object is very, very simple, is simply to print out all of the properties in it and their values, which it did. The first property is called name, second property is called name2. The value in the first one is a string set to my name. The value in the second one, it's a double precision floating point number containing 67.56. That object is now lost. I didn't save it. I didn't assign it to a variable. I didn't do anything with it. That object is gone. So if I wanted to save this object, I would want to assign it to a variable. I could also take this object and send it through a pipe, or redirect the default output to a file. If I send this through a pipe to getMember, I'll be able to see exactly what I built with my new object command. And we'll see that we created a PS PowerShell custom object. It has 4 methods. I mentioned it would have equals and get type. It also has toString and something called get hash code. And there are the 2 properties that I built. You notice one is a string, one is a double. Because this is a custom object, those properties are of a special type called note property, meaning they can't be changed. Now that's not strictly true. They can, but for printing purposes, they just print as strings. You can create as many objects as you like in PowerShell. When you create your objects, if you assign them to variables or put them in as properties of other objects, they'll hang around until those objects or the variables go away. You can make as many as you wish. You do not have to start with the empty PS object. You can start with an existing object and add new properties to it. For example, if I were to use, instead of starting type PS object, if I were to use type system datetime, the same kind that comes out of getDate, and specify properties of name and name2, I'm going to have a problem. And the reason is, I've tried to tell it exactly which properties it should have, and it already has properties, and my names don't match them. So you can use other types to start with, and if you do, you're going to have to use something other than specifying a complete property list. You're going to have to look at the new object commandlet and see what your other choices are for adding and removing properties in that object. Let's look at a couple of examples. We've done one already, creating an object starting with PS object that has 2 properties with some data in them. It is very similar to the one that is on this slide as the first example, so we're not going to do it again. I will point out that in the example on the slide, I used the words key1, key2, and key3 for the 3 property names. I used value1 and value2 in the definitions of the data that was being placed in those properties. I kind of did that on purpose it's worth pointing out that an alternate name for these things is key value pairs. Now, these are actually object properties, and that's what they should be called. But quite often they're referred to as key value pairs. When we're creating objects, sometimes the objects we create allow us to fill in interesting information. You'll notice that when I tried to create an object of type system datetime and assign values to properties, I got an error that said I tried to assign values to non-existent properties. Well, that's because datetime already has a property list. I can assign values to properties that are already in there. I just have to tell it which properties and assign values that are of compatible types to those existing properties. So, if I were to look at the definition of the properties that are in a datetime object, by getting a datetime object using the getDate command, piping it to getMember and saying, show me only property member types, I can see that there are quite a few of them in here. Notice that one of the properties in here is called day of week. The day of week property is of type system day of week. Now, when we ran getDate, we got a pretty printout of our date and time, but you'll notice the day of the week is not there. So if I wanted to know what day of the week it was, I would need to run getDate, put parentheses around it to get the handle, reach inside with my dot, and ask for the day of week property. And I'll find that it is Tuesday, which looks like a string. So you might wonder, well, why is the day of week property definition not defined as a string? Well, let's find out. Let's take that object and let's send that to getMember to see what a system day of week object is really made of. And we'll find out it really isn't a string. It has a number of methods in it and one property called value underscore underscore, and it is an integer. It also can be not only retrieved, but changed. If you think about the day of the week, you'll be able to figure out why it's stored as an integer and not a string. For example, the days of the week have different names in different languages. So storing just one name doesn't make sense. The one thing that is universal is that a week is 7 days long. So by storing the day number within the week in the property, when we display day of week, the mechanism in PowerShell that displays that, which we won't delve into right now, converts that number to a string using the current time zone and locale to figure out how to display the day of the week. If I wanted to know what the actual number was for today, for Tuesday, I could get that day of week property, which contains a system day of week object, and reach inside that object with a dot and specifically ask for the value underscore underscore property, which contains an integer, and it will display the integer the way integers get displayed as a number. And I'll find out that Tuesday is day number 2. If I wanted to create a day of week object to use that corresponded to Wednesday, I could do that. I can make a new object of any type I like by saying new object dash type name and the type of object I want to start with. And if I start with a system.day-of-week, the object I'm creating will have that system day-of-week definition. It will have all of those methods and it'll have that property. And if I use my dash property syntax to assign values to properties, and I assign to an existing property that is something I can set, I can change, I could put in a 3, which my experimenting has already told me is going to be Wednesday. And this will produce a system day-of-week object. It will set the integer to 3, the integer value to a 3, and that object will be dumped off the end of the command line because I didn't tell it what to do with the object I made, and it'll wind up displayed on my screen because PowerShell will catch the day-of-week object falling off, look inside, find the 3, and convert that to a string to tell me Wednesday. Creating values for your properties does not have to be as simple as just putting literal text or a number right on the command line. Anything you can do that will build an object or collection of objects can be used to assign values to properties. The third example on the slide kind of jumps ahead a little bit in that it has in it a loop, a for each loop. But let's look inside the loop for the moment because that's the part we're interested in right now. Creating objects. So in there we have a command, new object. The type name we're going to start with is ps object. So that's a nice empty object with no predefined properties, so we can make our own. We're going to say dash property because we're going to make a list of properties. We're going to open up our list with @ curly brace. And because we're planning on typing quite a bit in here, instead of putting the list of properties separated by semicolons all on one line, I'm going to press enter. PowerShell will recognize I've opened a list of properties and not finished it yet, so it gives me a special prompt, the double greater than, that says, keep going, you're not done typing your command yet. So I'm going to put in here my property list, which has to be specified as property name =, value to put in the property. I'm going to create one called place count, and I'm going to assign to it a 2, just for fun. Remember we said that if we're creating more than one property, we need to put semicolons between them. So we'll put our semicolon and press enter. We'll keep going. We still haven't closed off our list with the closing curly brace, so PowerShell says, keep going. What else have you got? And I'm going to say, create me something called max value in binary. Now what I mean when I say max value in binary is I'm saying if I had 2 bits, what's the biggest decimal number that I could represent? Well, I know I could have, with 2 bits, I could have 0, 0, which is decimal 0. I could have 0, 1, which is decimal 1. I could have 1, 0, which is decimal 2. And I could have 1, 1, which is decimal 3. So there's actually 4 possible values for my 2 bits to have. The way that that works in mathematics is basically we take the base of the numbering system, binary is base 2, and we raise that to the power of the number of digits we have, number of bits in this case. To do math in PowerShell, there are a number of options. We're going to use one for demonstration purposes that's kind of interesting. We're going to use a special syntax, which is square brackets, library name, square bracket, double colon, and the name of a function to say, reach into the included PowerShell math library and look for a function called pal, which is the function to raise one number to the power of another. This is a function, it's like a method. We can include parameters. We're going to say it's going to be 2 to the power of our previous number, the place count, the number of bits, in this case 2. So it's going to do the math, produce a number, and stick that number in as the value in the property we are creating, which is max value in binary. We can do this to generate the maximum value, the number of combinations, for any number of digits in any numbering system. So let's put our semicolon and make another property. Let's make one called max value in octal, which is base 8. So we would calculate it a similar way. We would use the math library, reach in, find the power function. Octal is base 8. We are saying that we have 2 places, 2 digits to work with. So we're going to raise it to the power of 2. And the result of that will be the number of combinations you can have with 2 octal numbers, 2 octal digits, octets. If I wanted it for hexadecimal, I could make another property. I'll call it max value in hexadecimal. Again, generated the same way with some math. This time, we're going to use the base of hexadecimal, which is 16, and raise it to the number of places. And this is going to be our last property, so we don't need another semicolon before the next one. There is no next property. This is our last one. So we'll close it off with a curly brace. So to recap, we are creating a new object. We're starting with an empty PS object. We are specifying a property list that begins at our curly brace and ends at the closing curly brace. There will be 4 properties with the following names, and the objects to put in them are created in a couple of different ways. We aren't telling it what to do with the object, so it's going to fall off the end of the command line. PowerShell will catch it and will display our new object, which has 4 properties. You'll notice these properties are not output in the same order that we input them. That's because they're not stored as simply as you might assume. So, if we have 2 places in our number and it's a binary number, there are 4 possible combinations, 4 possible numbers it could be. If this was 2 octal digits, there are 64 combinations we could have. And if there are 2 hexadecimal digits, there are 256 possible combinations. That looks like a lot of work to create an object to do that. Why not just generate the 3 things we wanted? Well, if what you're doing is very simple, it doesn't make sense to make a whole object for it. But what if I wanted to make a whole bunch of these? What if I wanted to make a table where for different place counts, different numbers of digits, I wanted to know what the maximum value for all of these things was? Well, that is precisely what this loop does. For each $C and 1 to 4, it's going to put 1 into the C variable, then 2 into the C variable, then 3 in the C variable, then 4 in the C variable. Each time it puts in one of those numbers, it's going to run this. And you'll notice in my script, I put in the place count, and I typed in the place count over and over. Well, in this script that I've got on the example slide, the place count is the number in the C variable. So I'm going to use that C variable everywhere. So now what we're doing is we're putting a for each loop around this. It's easy. And everywhere that I have the place count, I'm going to use a variable to get my place count. kind of writing this in a backwards way, but just to show how it's built. So in order to use that C variable that way, I'm going to have to put a value in the C variable. And I'm going to do that with a loop, because I'm going to say for each that $C should come from a collection of integers starting with 1 and going to 4, that we're going to have a loop running. And inside that loop, we're going to make a new object. With various properties. And after making our new object, that's all we're going to be doing in our loop. So we'll close our loop and have it go back and do it again. So it's going to make a new object, then make another new object, then make another new object, then make another new object. So what's going to come out of this command line now is a collection of objects for all these different values of place count and calculating the values of the other things. And since it's producing a collection of objects, and those objects, as we already noticed, come out looking like a table, we're going to produce a table showing all the different values. And this is where creating your own object starts to become very powerful. Once you have defined the structure of your object, what's in it, and how it's built, you can very rapidly make many, many, many of them with different values. This can be really, really helpful. Custom objects. Kind of like custom variables, but much more sophisticated.